All right, so this is 13.1.51. They're asking us to solve the formula y is equal to 1 plus r over m to the mth minus 1 for r to obtain a general formula for the nominal rate in terms of yield and the number of compoundings per year. Okay, all right, and so if we're solving for r, the r, let me write the formula out here. The r is right here on the inside of these parentheses that's raised to this power. So the first thing that we're going to have to do is take the 1 to the other side so that we can isolate that term. So we'll have y plus 1 equal to 1 plus r over m to the mth power. Okay. Now what we need to do is take the mth root. So anytime we have something raised to a power right here, we can use the mth root, or whatever root this is to, in order to clear that. Okay. And so this will become 1 plus r over m equal to the mth root of y plus 1. And this, as a reminder, is because our exponent rules here say that when we have fractional exponents, if we have this nth root here, if I just have x, the nth root of x to the first, the nth root of x to the first, this would be equal to x to the 1 over n. Okay, so this ends up simplifying because we'd have the mth root of m, and this is 1 over m times m, so it just ends up going away there. Okay, just as a review of exponents. And then if we're still solving for r here, we're going to subtract 1 from both sides. And this is now the mth root of y plus 1. This is under a radical, so we can't subtract 1 from it, so it's going to be off the end. And that's equal to r over m. And then last thing here, clear the fractions. We're going to multiply both sides by m. And we're going to get r is equal to, and I'm going to go ahead and actually distribute that m through, so I don't have enough room to write that there. So we'll actually end up getting, when I distribute the m, it's going to be m times the mth root of y plus 1. That's multiplying by that, and then multiplying by that would be minus m equal to r. Okay, and so this is the formula that we can use to actually calculate finding the nominal rate corresponding to an effective rate, that will be given to us. Okay, so we're actually going to use this formula in the next problem, which is 13.1.52. So I'll just move to that problem now. So this problem is asking us to find the nominal rate corresponding to an effective rate of 5.86% if interest is compounded quarterly. Okay, so we're actually using this formula. That's why they had you calculate that first. R is equal to m times the mth root of y plus 1, and then we have minus m off the end there. Okay. And so we're supposed to find the nominal rate. That's actually r. And the effective rate is our y there, and m is the number of compoundings. So the y ends up being 0.0586, and the m here, because we're compounding quarterly, that's 4 times a year. So we have those two values. Okay, so we're going to plug those into our calculator, or into our formula, and then into our calculator. So we have 4 here. This is the fourth root of 0.0586 plus 1, and then minus 4. Okay, so r here equals 4 times the fourth root of 1.0586, and then minus 4. Okay, on your calculator you will either see a button where you can input the fourth root here, or you may need to do it in a fractional exponent form. This is 1.0586 raised to the 1/4 power. So the way I'm going to do it with the fractional exponent. So I'm going to plug in my 1.0586. I don't know if you can see that very well. And then I'm raising that to the 1/4 power. I need to put parentheses around my 1/4 so that it takes it as that whole entire power right there. And then I'm going to hit enter. So I get this number right here, 1.014338646. Okay. I'm going to go ahead and keep that in my calculator, and I'm multiplying by 4 as the next step, and then I'm going to subtract 4. And what we get here is 0.05735, and it goes on. They did ask us to round to just 1 decimal place here for the percentage. So changing this to a percentage, it would actually be 5.7%. And that's it for that problem.